Good afternoon, students. Today I will explain you refraction through a prism and calculation of total deviation by a prism. So, calculation of angle of deviation by the prism. So here, for your convenience, we have taken. Let me adjust the camera first. Hmm. First, we have taken ABC, a triangular prism. Okay, and then we have made incident OP through reflecting surface AB, and it incidents here. And this is air, this is rarer medium because it is air, and this is denser medium because this is glass. So the light will bend of towards the normal, isn't it? So light bends towards the normal. This is the normal, and this is the SN is the normal at reflecting surface AB. So it bends towards the normal, and for this reflecting surface AC, this this ray of light, namely PQ, is the incident ray, right? So this is the denser medium and this is the rarer medium, and there is KN, a normal drawn at AC. So when this PQ incident ray strikes at AC, it definitely will go to outwards, like away from the normal, isn't it? Because this is the denser medium, this is the rarer medium, and we know when when an incident ray travels from denser to rarer medium, it bends away from the normal. That's why Kn is the normal and PQ bends away along QR. Okay, now let's look at the notes. So calculation of angle of deviation by the prisms. Let ABC the prism. I explain you all. Now for surface AB, let me explain the diagram first. Okay, for surface AB, SN is a normal at point P at surface AB. Angle OPS is angle of incidence, namely calibrated I1. Angle QPN. Where is QPN? Let me see. QPN. Okay, this angle is angle of diffraction. Okay, and MPQ, this is angle of deviation by this calibrated with delta 1. How this is the angle of deviation? Because you see, this is the incident ray passing, and this is the dotted line. Okay, so the light should have passed from here if there was no presence of prism, but since there's a prism and there's a deviation means bhatakna. So jitna bhatka angle, that is the angle of deviation. Okay, same for this surface, this is the angle of deviation because light should have passed from here to here, but it deviated along this thing. Okay, next, now let LMQ be an angle, and let's calibrate the angle as delta. Okay, now from the geometrical concept of triangles, we know that the sum of interior opposite angles equals to the exterior angle. So for triangle PMQ, the exterior angle is LMQ, and these are the interior opposite angle. So delta 1 plus delta 2 will equals to this LMQ. That's what we have written, because LMQ we have calibrated as delta, so delta equals to delta 1 plus delta 2. now now uh, now can we write delta 1? So our equation is this. We have delta equals to delta 1 plus delta 2. You see, this is delta 1, and if you see SPO and this LPN, doesn't it seem like a vertically opposite angle? So this angle equals to sum of these angles, isn't it? So angle of incidence equals to delta 1 plus angle of refraction. So can we write delta 1 equals to angle of incidence minus angle of refraction? You like this, delta 1 equals to angle of incidence minus angle of refraction. Okay, and similarly for delta 2, if we see this is a vertically opposite angle, so angle of incidence minus angle of refraction, no, this is also a incidence, okay? So this will minus equals to this one, so we can also write this thing as angle of I2, this is emergence also, minus angle R2. Okay, now this can be further simplified as delta equals to angle I minus angle R plus angle I2 minus angle R2. Okay, we rearrange it, so angle of incidence 1 plus angle of incidence 2 minus angle of refraction 1 plus angle of refraction 2. Okay, this is the concept. Now let me tell you one thing. Now can you see this is the formation of here 90-degree, and this is the formation of 90-degree, isn't it? Because Sn and Kn is perpendicular to surface AB and AC respectively, isn't it? Now if we closely observe the quadrilateral APNQ, okay, this is a linear pair, isn't it? If this is 90-degree, this will be also be equal to 90-degree, and if this is 90-degree, this angle here will equals to 90-degree. So 90-degree, 90-degree, 180-degree. Left is what is the total sum of the interior angle of quadrilateral? That is 360, right? So we can write is as this. So in quadrilateral APNQ, oh, so I have to show you. Okay, can you check this diagram and then further proceed? So in this quadrilateral AP angle APN, where is PN, this plus AQN plus PNQ plus PAQ equals 360-degree. And now PNQ can further be written as angle 180 minus R1 minus R2, isn't it? Because this is a triangle formed here, so we can write in quad AP, in quad AP NQ, okay, angle APN, okay, plus angle AQN plus angle P and Q. I'm not writing, you can check. Okay, so PAQ, sum of interior is 360-degree, and APN and AQN, namely APN and AQN, I have just told you that it is 90-degree and it is 90-degree, so the sum of these are 180-degree. Okay, plus P and Q, I said you that P and Q is minus R1 minus R2. So 180 minus R1 minus R2, and PAQ can also be written as angle A, isn't it? Plus angle A equals to 360-degree. So 180 plus 180, 360, 360 minus R1 minus R2 plus angle A equals to 360-degree. This is cut. So angle A equals to R1 plus R2, isn't it? So in this equation here, R1 plus R2 can be written as angle A. So and delta equals to angle I1 plus angle I2 minus angle of refraction, that is angle of prism. Thanks you. Oh sorry,